Hello all, good morning. Welcome to this Docker section. Okay, so today we will be talking about the Docker Compose. Till now, we have discussed about a lot of things like what are the Docker images, then what are the Docker containers, how to build an image and push it to the Docker Hub, how to persist the data with the help of Docker volume, and post that how Docker containers communicate with each other, which kind of the network they use internally, so it's a bridge network by default. Okay, and the last part is like a docker compose. Now why do we need docker compose and what is the main purpose? Okay, so let me share with a scenario to you guys so that things will be definitely easy for you to understand. If you have some idea about the two-tier architecture, then within the two-tier architecture, okay, nowadays we are using the three-tier architecture, but in the previous almost 5 to 10 years back, there was only two-tier architecture. Okay, within this two-tier architecture, there was something like front-end services or front-end applications, you can call it as, and there was some back-end application. It was up and running. Okay, now for the front-end application, people might used to have worked with HTML or CSS, and for the Java, they used to work with, let's say, for the backend one, they used to work with the Java, C, C++, any kind of backend language. Okay, and definitely, if you talk about, let's say, a Flipkart, then the front end is nothing but the page you can see over here. Let's say if I talk about, go to the Flipkart website, then whatever you can see right now, okay, that is all nothing but a front end application, which is a kind of a web development as of now. And let's say if you click on any of the item over here, so internally link, this is going to open certain new page, and if you try to order any item over here, then it will go to the ordering service, then billing service it is going to follow. So it's not only a single application that is working in the entire Flipkart product. Okay, it's like combination of multiple applications. You can talk as one is a front end, second is like a billing, invoice, email, messaging, notification, alert, lot of applications involved within a single product. Okay, so those can be categorized as a front end who will work as a user interface to the all users. Okay, and one is nothing but the backend. And that backend is nothing but the code which is running in background. If you like try to order something, then internally it will process it. Okay, so all those things which is not visible to you right now, but it is working in the background, all those applications we can call it as a backend applications. Okay, and definitely always front end application will talk with backend application to process the data over here. And this is the kind of two-tier architecture we used to work upon in earlier days. Okay, now let's talk about, let's say, a front-end application over here. In that, let's say, uh, let me draw some diagram. Okay, so I'll talk about this as, let's say, a front-end application, and this is the BE stands for backend applications. Okay, and let's say we have defined a, or we have created a container for the front end, and we have created a container for the backend. Okay, now usually people used to connect to this front-end application, and they used to like look for the Flipkart page. They will just go through with entire website, look for certain product if they want to purchase. And suddenly, let's consider there is a big billion day in the Flipkart. So in that day, what is happening? They will have sale on certain items. They will have some discount. So because of that big billion days, the number of people, let's say, regularly used to hit to the Flipkart website is, let's say, 100, but on the day of big billion day, okay, there may be 1,000 or 10,000 people will be going to that website looking for any discount. Okay, so the number of people who will access to that website will definitely increase on particular day. Okay, so the number of requests to this container will definitely increase if the number of people who is going to access increase. Okay, so in that case, a single container definitely will not be capable of handling a lot of requests. Let's say if this container is capable of handling only 10 requests per second, and suddenly if this container receives 100 requests per second or 200 requests per second, then this container will get crash. This container will no longer be responding properly because the load on this container will be much higher as compared to the regular days. That's where we might need multiple containers of the same application. Okay, let's say this is also front-end application, this is also front-end application. So we might need a multiple containers of the same application, so that the uh, request will get directed towards each and every container. Let's say there are 100 requests per second now. So in this case, what is happening, if we increase the number of containers over here, then 33 requests will be handled by these, 33 requests handled by these 33. So the number of requests will be load balanced amongst each other. Okay, if we add one more container, then each and every container is going to handle 25 requests per second. So that is okay for those containers. Okay, so if you want to increase the number of containers over here, means in case of that big billion day, we can do so. Okay, same is the case for backend application as well. Like if the number of requests coming to this container is also uh, more, in that case we can increase the number of backend containers as well. And if in case of that big billion day, definitely we have to increase those number of containers, otherwise a single container definitely will not be able to suffice all the requests. That is the one thing you just need to understand now. Okay, next thing is like, now you till now you have understood, or till now you have learned, like if you want to create a container, the command will be like docker container run. DC is shortcut, let's say I'm saying, for the docker container. Docker container run hyphen d, let's say you, and from, let's say, nginx image, you can provide a name as well to this container. Okay, so this is going to create a single container. Okay, and let's say if you want 100 containers, then you have to execute this command manually 100 times to create 100 containers. So that is not I'm expecting. I want certain automation that I can always go ahead and create desired number of containers easily without executing commands repeatedly. So this is the drawback of this command currently, that it can create only a single container, it cannot create more than once. Okay, that is the main thing. And second thing is like if you want to, let's say we have created 100 containers over here in the front end, and now if you want to delete let's say 50 container out of that, so again you have to just go ahead and docker container delete, or sorry, docker container rm and container id or container name. So you have to execute that delete command uh, find 50 times to delete 50 containers. So it's like cumbersome activity to follow that, and that's where a docker compose comes into the picture. Okay, there are many benefits of using it. We'll talk about it once we do into practical. Okay, what docker compose is nothing but, it is nothing but a binary, okay, which provides us a tool for automation. Okay, what kind of automation we can do? We can create in that case you have to create a YAML file, okay, for the docker compose. So name of that YAML file will be docker-compose.yaml, and within that we have to write the content of the YAML, and in which basically we used to write a certain things like what will be the name of the container, what will be the sorry, not name of the container, like as you have to create a container, so from which image it should create, what should be the port mapping, what should be the volume mapping, environment variables. So all those things we can define within the docker-compose.yaml, and we can easily spin up the containers as many as we want. Okay, so once you do into the practical, definitely you will understood the benefit of having the Docker Compose. But before moving towards this Docker Compose, I just want you to understand this two-tier architecture clearly, so that you will understand how application is working internally. And in the Kubernetes section, when we will go there, that time we will learn the three-tier architecture as well, because nowadays the trending one is three-tier architecture. So you understood why we need to create multiple containers, and how this architecture works in layman language. Two tier is nothing but this is the first tier, okay, in which this is the front end layer of the application, and this is the first tier, this is the second tier. That's why we call it as a two tier. Okay, in case of three tier, there will be one more block over here that belong to the database, but we will not go into that detail right now. Okay, so we will just understand the basic one right now, then little bit advanced one we will do it later on. So this is the first tier, which, and tier is nothing but a layer you can consider, and that layer of application is the front end application. Second layer of application is the back end application, and always this front end application is visible to the users, and the way I have explained you for the Flipkart, that the page is visible for you to interact with. But in backend, certain JavaScript or Java or any other backend application is running over there. So always this, once you hit on a buy now, let's say on the Flipkart, then request will go to this backend, and some application is going to process that request. Again, it is going to send that response that you have to do the payment now. Then this person is going to do the payment. So likewise, this front end application and back end application is going to talk with each other on the regular basis. Okay, so you just need to understand the front end application is the first tier, back end application is the second tier in case of the two tier architecture. And why I have created multiple containers, because the regular traffic means, as usual, today is a big billion day, so definitely the number of persons or number of users who is going to access this Flipkart website is going to increase 10 times or 100 times. Okay, so because of that, whatever the current setup that we have, that will not be supporting to number of extra users. So that's where we have created extra containers to support those extra requests. And we can create such kind of architecture, we can easily create and easily maintain such kind of architecture with the help of Docker Compose. We can do so with the help of normal command as well, like Docker container run, but that will not be a automation, because as I told you, if you have to create 100 or 200 container, then you have to run this command 200 times, which is not a good practice. So that's where such kind of disadvantages of executing a single command multiple time can be achieved with the help of this Docker Compose easily. And this is mainly to create an entire application. Okay, so how we can do that, that you will get to know once we do the practical only. But at least you should get a point, like why we are learning this. Is it better now? Let's move towards then Docker Compose. And by default, Docker Compose is not installed on your system. Okay, if you want to install Docker Compose on your system, we have certain commands, two three commands that we have to execute. So in case of this Docker Compose, you will see installation. So just copy paste all these three lines over here, and this is going to download a Docker Compose for us. And as I have Docker Compose yesterday, I have installed it. so that's where it is saying the file already exists, but in your case this will not be the case. Okay, so what it is doing, the first curl command is downloading this binary file. What is the binary file name? That is nothing but docker compose. uh, this is the file. Okay, docker compose hyphen certain uname hyphen s command hyphen uname. So that is the name of the command, that is the name of the file. Okay, and that is getting saved under the user local bin with the name docker compose. So once we download this binary file, we are giving the executable permission to that binary file with the help of chmod plus x. So plus x is nothing but giving an executable permission to this binary file, and we are just creating a link so that that docker compose will be accessible from all the locations. As of now, this user bin, if I go to this location, ln-s is nothing but creating a soft link. So over here you can see this soft link is created, docker compose is pointed to this, and this user bin path is user bin location is already added to the path variable over here. So that's where this docker compose is accessible from all the locations. So now if you run docker compose and hit enter, this is going to show you certain commands and show you certain profiles options to execute further. Okay, so we will just go through it one by one. So installation is very simple, just execute all those 3 lines and your installation will be done on the this server. Now for creating a YAML file, let's create a simple folder, my DC, I'll say docker compose. Okay, and create a file with the name docker-compose.yaml. Okay, now what will be the content of this file? So we will just start with very basic content just to proceed further. So we have this file provided over here, docker compose1.yaml. Just open this. Okay, so this is the basic uh, docker compose YAML file. Okay, so what we are providing over here, we are providing the version of the docker compose that we are using, and over here we are creating a services is nothing but a layer that we can create. So what exactly services means, let me show you it one more time. So let's say this is the front end service, and within this front end service uh, we have multiple containers. Then we are going to create a backend service, and then we are going to have the multiple containers. Okay, so service is nothing but a load balancer you can consider over here. As we talked earlier, like let's say there are 4 containers, so each and every container will get a 25% of the request. Okay, so total there will be 100%. So similarly, who is going to manage, who is going to handle or take care of that, uh, each and every container should get equal amount of the requests. So that is nothing but a service. So you can consider service is nothing but a load balancer over here, who is going to balance the number of requests amongst the containers. Okay, so just consider this service right now over here, because within the practical things will be better clear. So service is nothing but a load balancer in case of the containers. And what will be the name of the service? This service name can be anything, it's up to you. Okay, so I'll just say that it is a front end service. Okay, so the service name is like user defined, whatever the name you think of. And now we want to create a container with the help of this docker compose. So from which image you want to create container? So right now I'll specify nginx is a image from which you want to create a container. So this is very simple to understand and simple to write as well. So this will be the static one, services also will be the static one. This front end, it's up to you what can be what you provide or prefer a name of your service. Right now I'll prefer front end, and from which image you want to create a container. So let's save this. And now if you want to execute this YAML file, so simply just say docker compose, as we have installed this binary earlier. So let's make use of this. Up is nothing but create everything which is written within this file. Let's say I said multiple services, so each and every service will a container will get created from each and every service. So right now front end is the only service that I am making use of over here. Okay, and if we just execute this file, means how to execute, if you want to like create a container, up is for creating a container, down is to delete the container. So whatever things which is written over here will get executed with the help of up command, and -d as usual in the detach mode. It means it is going to create in the background. Okay, so it has created a container over here. As of now, there is no way that you can provide a name to the container. A name to the container will get provided as per the standard syntax. Okay, I'll tell you how the name got created over here. PS is to check the like how, which all containers it has created. So it has created a container with this name. Okay, so front end is the name of the service, and this is the first container it has created. That's why underscore one. If you want to create one more container from this YAML file regarding to this service, then that name will be underscore two, underscore three. So it will keep on increasing. And this my DC is nothing but a folder name over here. This is the folder. So always a container will get created with this standard naming format. Okay, the name of the folder underscore name of the service underscore it will start with one. Again it will start with if I increase the number of containers, how can I increase the container? Just by saying scale किसके नंबर ऑफ कंटेनर्स बढ़ाने हैं, फ्रंट एंड सर्विस के नंबर ऑफ कंटेनर्स बढ़ाने हैं. Let's say I want to make it to 5. Okay, so I want total number of containers to be 5 for this service front end. In that case, I just have to make use of this scale command and provide how many containers we want for that service. So earlier there was one container already created, so it has created 4 more containers. So that's why you will see over here 2, 3, 4, 5. So one was already there, and so that's why it has created 4 extra containers. And now if you see docker compose ps, so total number of containers are now 5. So if you specify over here 100, so definitely 100 containers will get created. Let's say if I specify 10, now you know, or docker compose already know that 5 containers are already there, so it will just create 5 more containers. So total we will be having 10 containers. So it will keep on increasing if you increase the number of containers over here. So total we have 10 containers, 1 2 3 4 5 6 7 8 9 and 10 over here. So let's say this is a big billion day, that's why I have created extra containers, and let's consider tomorrow big billion day ends. So even in that case I don't need to have lot many containers. I am okay with 2 container as well. So just specify front end equal to 2. So it is going to delete the last 8 containers, and it is going to keep only first and second. So we don't have to manually like delete it one by one. It is going to take care of that. So if you say scale front end equal to 2, so that this 2 is nothing but a desired number. Okay, so this is the desired state and this is the current state. So current state is saying we have 10 container, and desired state is saying I want only 2 containers. So it is going to delete all the 8 containers, like 3 4 5 6 7 8 9 10. It is going to keep only 1 and 2. So we have 1 and 2. So it's very easy to increase the number of containers and decrease the number of containers with the help of Docker Compose. So whatever things we have learned so far, all those things will be useful in case of this Docker Compose. Okay, so this is the one use case and the best use case as of now regarding the Docker Compose. Okay, now let's see the one more use case. As I talked about a front-end service and back-end service, so this service act as a load balancer and back this service also act as a load balancer, but any request that is okay, let me frame it like okay, so any request that okay, meanwhile maybe create 1 2 3 4 containers over here for the front end service, and let's say 2 containers for the back end service. So any request that is coming to this front end service, okay, so let's say first request come, this is going to redirect the request to the first container. New request comes, this new request will come to the second container, again third, and then fourth. So likewise each and every request will get uh, uh, transfer to the next transfer to the containers in the round robin fashion. Again fifth request will come, that fifth request will go to the first. Then in the round robin fashion each and every container will get a request from the service in sequence. Same is the case this container is, if you want to talk to this backend servers or backend containers, in that case this container is going to talk to the service, and internally this service will have the communication with the backend containers. So this is how entire flow is going to execute with the help in case of the two-tier architecture. So the load balancing, whatever the requests that are getting accepted by the front-end services, that request should be distributed equally amongst all the containers. That is the main purpose of the service. Okay, so in short, service will have an idea how many containers are there in means how many containers are there to send the request. Means this service definitely should know ki how many containers are present under that. This service also should know how many containers are present under that, so that and each and every information about that containers should know or should have uh, information should be there within the front end service. Okay, so how you can say practically that service is something which will have an idea about all the containers which are present under that. Okay, so in that case, just to show you a proper demo, within this front end service I have created total 4 containers. So I want this front end service, this is how I can see front end के 4 container है, but how you will say with the guarantee that this front end service really know the information about these containers. Okay, so if you want to just test it out, log into any of the container, let's say docker execute -it, log into any of the container and do ns lookup. NS lookup is just to check the host name. It's a resolution of host name to the IP address. Okay. So we have this front end service. So let's do NS lookup to this front end service. As of now, NS lookup is not installed. Okay, not an issue. Let's go ahead and install the NS lookup on this container with the help of this command. First of all, let's do the apt update, and then next run this DNS utils command, provide y. So now you can see this front end IP address we can see. Okay, So let's talk about this ns lookup and front end. Okay, front end is a service that we have specified, and this service is getting resolved into the 4 IP address, like ending with 2, 3, 4 and 5. Okay, why there are 4 IP address? Because there are 4 containers, and these all IP address belongs to the container IP address. Means if you just see on docker container ps, and let's talk about which containers, a front end containers. Okay, what are the name? Okay, these are the containers I'm talking about currently. Now if you just inspect to these containers, their IP address will be starting with 172.23.02. So वन जो फर्स्ट कंटेनर है अपना, उसका IP एड्रेस विल बी एंडिंग विथ 2. सेकंड कंटेनर है, उसका IP एड्रेस एंडिंग विथ 3. थर्ड का दिस, फोर्थ का दिस. So likewise, if you want to see, definitely I can show you. Docker container inspect. Over here you can see IP address ending with 2. इसका IP address should be ending with 3, ending with 5, ending with 4. So likewise we will get a IP address over here. So that's what I was trying to explain, that this front end service. Okay, so front end is kind of a load balancing thing which is going to send request to the internal IP addresses. Okay, let's see if I delete the 2 containers out of that, and let's say I'll keep only 2 containers and let me delete the other 2. And now if I see the ns lookup of front end, I can see only 2 IP address, because I have only 2 containers. So that's why this service is getting resolved into only 2 IP address, nothing else. Okay, so ns lookup is mainly for resolution purpose. Understood this much? It's quite technical, but we should know this. One more thing I can talk about it, that is nothing but this service act as a load balancer over here. Okay, that we just discussed now. So in this case, let's say if this container gets deleted and I create a new container over here, it will not even matter to me, because directly I'm not sending request to the container, I'm directly sending request to this service. So for the end user, how many containers are there in the background doesn't matter. It's not even visible to that end user as well. Okay, only what matters is this front end service is available or not. So, and this service will take care of the underlying containers directly. So there is if this container also get deleted, so if there are total 3 containers, so the request will get divided among the 3 containers. So it doesn't matter like how many containers are there, only thing should be each and every container should not be overloaded. Okay, and even let's say this container gets deleted, and if new container gets created, and this container will have some different IP address. Let's say the deleted one will be having 1.1.1.1, and the newly created, let's say, have 2.2.2.2. So that even doesn't matter to me, because this container, if you want to talk with the backend containers, then there is a medium to talk. It's not directly container to container communication happening, because the container IP address will change over the time once it gets restarted or deleted. So that's where there will be a certain medium to talk about, and that is nothing but a service. And so service will act as a load balancer plus a interface between the front end and back end. So this is the main thing which definitely we should know about this Docker Compose. Now let's learn some other things, like with the help of Docker Compose we can even build an image as well. Okay, so it's not like only the image which we have provided over here. We have to go ahead and create a container from that. Instead of that, we can ask our Docker Compose to build an image from a Docker file and create a container from that. Okay, so let's say I'll say build dot. Build dot is nothing but the Docker file is present at the same location, so it should build that Docker file first, and then it should create a container from the newly generated image. Okay, so that is my requirement. So before that, what I'll do, I'll just delete everything. To delete everything, as you know, we have docker compose ps, so these two containers. So you just have to make use of the down. Up is to start all the containers, down is to stop it and remove it. So you can say stopping these containers, removing these containers, and network, it is going to create. We'll talk about network later. Okay, so it has stopped and removed the container. Now what is the content of my docker compose? This build dot. Okay, so let's write a docker file. Simply I'm not going to run touch. Simple docker file we have written, and we are going to now we have this docker compose file, we have this docker file, and we want to create a container from the newly build image. Okay, so this docker compose is going to build the image from this docker file, and once it build, it is going to create a container. Okay, so before doing so, let me delete everything. So there these many containers are running, so let me delete all the containers. Docker ps hyphen. Okay, I don't have any container over here. Let me check for the images. So these many images are there. Let me delete this. Okay, so we have a single image nginx, that's all. Okay, so let's talk about one more time docker file and docker compose. Let's build this docker compose. Okay, same thing, docker compose up hyphen d. Internally this docker compose will look for a docker-compose.yaml, and it is going to execute everything for us. Now first of all, it has uh, like it is building an image. Okay, you can see building front end, sending build context and all those things. Step one is to from step one is from nginx. Step two is like this, just create a blank log file. So it has created a image first, and what is the name of the image? Name of the image, like this folder name underscore service name, and latest is the default tag it has provided. Okay, and along with that it has created a container as well. It's not only like building an image and nothing else. So along with that, it has created a container with this name, and this is the container which I can see. And if you want to scale it, definitely you can do hyphen scale and front end equal to that. So that we already saw. So one more use case of the docker compose is like you can have your docker file, and without even building manually that image, docker file will help us in building it automatically along with that container will also get created from that image. So if you just go within this container, this one.a.log, whatever file we have created within the image, it's available over here. Okay, so this is how we can make use of it, and we have some warning over here, like whenever you are going to uh, change the docker file, in that case you have to make use of this hyphen build command. Otherwise it will just it will even not look for that extra content or new content that we are adding within the docker file. What I mean to say, if I, let's say, open the docker file and add one more content over here, let's say b.log, and we say docker compose up hyphen d, so it will say it is up to date. Even though I have added something extra within the docker file, modified the docker file, it will still say it is up to date. So in that case you just have to say what was that command which was expected, hyphen build. So this is going to build it and again recreate it. Okay, so it has same thing from nginx, and then one.log, a.log, b.log, and it has recreating the container. Earlier there was a container already running, but that was running from the previous image. But now we have generated a image from the latest docker file. Name of the image will remain the same. Okay, name of the container will also remain the same, but it has recreated it. So anytime you change the docker file, just run this hyphen build command. Otherwise the change that you have done in the docker file will not be into the effect. So if you want to keep this some different name of your docker file, then in that, sorry, docker compose file, in that case you have to provide that file name over here, that you have to execute this file. So if you want to go ahead and make use of some other, I mean to say some different name, like some other than the docker-compose.yaml, then you have to provide a name of that file with this. And you don't want to provide this, then you always have to go ahead and create a file with a standard name, that is nothing but docker-compose.yaml. Okay, so let's rename it again, and as of now we are up to date, means one container is expected and that is already created. So that's why it is saying it's up to date. Along with that, there are multiple use cases of this. It's not just for creating a container. Along with that, we can have volume attached, means we can have the content related to the volume, we can have content related to the port mapping, then environment variable as well. So all those things is also possible with the help of this docker compose yaml. Okay, so maybe let me show you something. Let me delete this first so that everything will be cleared. So this is one of the docker compose file I got from the internet, and in which what is happening over here, we have one service with the name as db, and it is going to, a container is going to create from this image, and we are doing the volume, means I mean to say we are attaching a volume to this for the data persistence. It means a volume with this name db underscore data will get created, and this will get mapped to this directory within the container. Okay, so this directory belongs to the container, and this db underscore data belongs to your host name. Okay, like a docker host you can consider. So that if this container even gets deleted, there is no issue. We will still have the data available over the docker host inside this volume. And these are certain environment variable I can add within this docker container. Okay, so this is the user like a variable and value. So likewise I can add as many environment variable as I want. it's up to me. Okay, so within the container, okay, so container will get created from this image. That container will have volume attached to it. Also that container will have this environment variables present within that. One more service I can create in the level of the DB. You can see there is a WordPress. Okay, this level is important. When we will learn the Kubernetes, that time we are going to write a lot of YAML files. There you will your YAML related queries or YAML related how to write a YAML file, what exactly is the YAML file. Those things will get definitely clear because Kubernetes is all about YAML file writing. Okay, so this DB and WordPress are on the same level. So this WordPress is also one of the service. So I can write as many service as I want. So whenever I'm going to create a or whenever I'm going to say docker compose up -d, so a container will get created from this and a container will get created from this as well. So two containers will get created at a time. Okay, so depends on DB. We can say till the time this container is up and running, this WordPress related container will not get started. That is the meaning of depends on. So once this container gets created, then only a WordPress related container will get created. So this WordPress related container will get created from this image. Same thing, we are doing the volume mapping, we are doing the port mapping as well. So what we are saying, it's like a port mapping. So 8000 belong to our Docker host, 80 belongs to the container. So we have to access this website over the port 8000 and certain environment variable we are defining over here. And these are the volumes that we are mentioning over here, like DB data and WordPress data. So to get that volumes created, we are specifying like this. So those volumes was not present earlier, so those volumes will get created with the help of this volume command. So whatever things we have just seen within the Docker section, like what are the images, how to create it, then volume related also we have seen it, then environment variable, what are the environment variable that we have seen, port mapping we have seen, and each and everything will get created in a particular network. As we have saw earlier in the yesterday's section, if this is the Docker host, let's say this is the Docker host, and let's say this is the Flipkart one, and let's say this is the Amazon one. So whatever containers you are going to create within this Flipkart, let's say this is the Flipkart network, this is the Amazon network. So whatever containers you are going to create within the Flipkart network, those containers can communicate with each other. Okay, so these three containers can communicate with each other. Those three containers can communicate with each other, but these containers cannot communicate with each other, which is good idea because these two are the different applications, and within two not application, product I meant to say. So Flipkart container should never connect with Amazon container and vice versa. That's where a networking will help us. So if you create this three container in first network, if you create this three containers in second network, so this isolation will happen and only these containers can talk amongst each other, not uh, across the network. So that's where whenever you are going to create anything from this Docker Compose, a automatic network will get created, and all those containers will get attached to that network, so that I will consider this entire as one application, and this one application, not one application, I will consider this entire as one product, and this product will have everything within that. There is nothing we have to write extra. Okay, so the containers which are going to create within with the help of this Docker Compose, they can talk with each other definitely, but they will not be able to talk with the third container or any container which is getting created outside this Docker Compose. Let me show you practically. Let's say Docker Compose up -d. So you can see creating network this. So always a network will get created, and whatever containers that we are creating, all those containers will have this network attached to that. Okay, the thing is MySQL image was not present on my system, so that's why it has downloaded that image first. Same goes for the WordPress image was not present, so that's why it is pulling the WordPress, and now it has created the container. One is database container, one is a WordPress container. If you inspect this WordPress database container, and if you see the network, this MyDC is the network attached to it. Same goes for WordPress. Okay, so both these containers is attached to this, so that's why these two containers can talk with each other definitely. Okay, so whatever containers that we are creating because of this docker compose file, all those containers will get attached to the network which it has created by default. Okay, over here, where is that? Yeah, over here it has created this network, and all the containers within this docker compose will talk, because each and every container will have this default network attached to it. So this is the fundamental of network. Yesterday we have saw, and a docker compose internally using the network for internal communication. We don't have to worry of the network creation over here. So docker compose is, if you understood, this is nothing but a kind of automation tool for entire docker. Okay, so we can write uh, all that whatever things we have learned so far within this docker from the day one, we can make use of each and everything in the docker compose. Okay, so like we can create a containers within the docker compose, then we can make use of the docker file within the docker compose. We can push is something not required right now. We can create or map a volume or attach a volume with the help of docker compose, create a default network. So whatever things we have learned from the day one, all those things we can make use of in the docker compose, definitely, like port mapping and then environment variable creation, so all those things. And there are some extra commands which I have mentioned over here, like down is to just bring down everything, delete everything. Then build is to build an image. Then up hyphen d hyphen build is if there is any change in the docker file, then you have to rebuild the image. And then ps is to check which all processes, stop to stop the container, start container, restart container, check logs of the container. Top is to just check how which all I meant to say memory or CPU consumption. Let me check that. Compose ps, these all two containers are running. If I say top, okay, so this top is all about which all process ID is running. So this is not much important, so don't go into that. It's all about like which all process is internally running, what are the process ID. It's not that important. RM is to remove the containers, and then kill is to kill the containers. So let's not understand, or let's not go to the small options, because that is not something you will keep in mind, and that is not something we'll ask into the interview as well. Interview will just check the information, or will just check the technical knowledge on the docker compose, why we are using it, how to use it, and just whatever we have discussed so far till now. Okay, small options even he will not mind. Okay, so keep an idea about docker compose and high level commands that we have used within this. Okay, that's all from my end. Thank you so much for joining. Bye bye, take care.